Saxon Algebra 2, lesson 59. Today we're going to talk about polar coordinates a little bit more. And we're going to handle something new, but I'm also going to back up and start from the beginning and go forwards so that we do a bit of reviewing. I know these coordinates are really a challenge to make sense of in the beginning, but trust me, you will get the hang of them and you'll be cooking with gas before long. But let's remember that rectangular and polar coordinates are two ways to locate points on a Cartesian coordinate system. Rectangular we're used to, polar is new and kind of weird. And we've learned a little bit, just enough to be dangerous, about how polar coordinates work. But I'm going to start from the beginning and remind you of how we deal with them. We're going to take a set of polar coordinates. And we're going to decipher them and we're going to graph them. That's going to be our first step. Now, they always have this weird little thing. That's how you know it's polar coordinates. They're kind of weird. This little shape is kind of weird. We've never seen that before. But what it does is it creates a little compartment. This tells us how many degrees. I think of it as the number of degrees from go, and I'll explain what I mean by that later. This is the length of our hypotenuse. And you say to yourself, hypotenuse? What are you talking about, hypotenuse? There is no hypotenuse. I know, there will be one. We always start with working on the degree side first. And what we do is we draw just a basic thing. We don't put any number line information on here, but we remember that go is right here. We start here, and we start measuring our degrees this way, right? These are our degrees. We measure them from the go spot, and I need 211 degrees. Now I remember that every quadrant is worth 90, right? That helps me. So as I start to travel in this direction, I add up how many degrees I've got. 90, 180. I still need to keep going, right? But I don't need to go another whole quadrant because that will get me to 270. So I know that my angle's somewhere here in this quadrant. Now I'm at 180. I need 211, so if I subtract 211 minus 180, I'll find I need 31 degrees. Now I can fairly arbitrarily just draw a line through here, roughly where I think that should be. I draw a line that I think gives me about a 31 degree angle right here. And I draw it out a ways just so my picture looks nice. And then I connect it back to the x-axis. We always connect back to the x-axis. It's just the way it works. We never go to the y. That really bothered me when I first started doing this. But just accept it, right? Now we see that if we draw the line that goes all the way around to here, that is indeed 211 degrees. All right? That's the trickiest part of graphing polar coordinates, is just adding up the pieces so that you get the full number of degrees you need. The hypotenuse is super easy. Now that we've drawn this line out to create this angle and then connected it back up, we see, oh, we do have a triangle after all. Hypotenuse is always opposite. I shouldn't say opposite. It's across from the right angle. This is the hypotenuse. Okay, and I want to draw, I'm going to reorient the triangle, but I want to make sure we have this in front of us. No matter how the triangle is drawn, we look at this marker first and go across, and that is the hypotenuse. That's always the same. The other two sides are relative depending on which angle we're orienting toward. As mathematicians, we typically put the angle we're interested down at the bottom, whether it's over here or if the triangle's flipped this way. We typically orient the angle we want to this side, but I like to draw a little picture of a person just to remind us that's where we're orienting. Once we figure that out, then we know, okay, this side is the side next to us, that is the adjacent side. And the side that is farthest away, that is, here, I'll write it this way, the opposite. Hypotenuse is easy to find because it's always directly opposite that right angle marker. Adjacent and opposite are relative to where we're standing. If we were standing up here, then this would be the one next to us, so that would be adjacent. And this would be the opposite one. So we have to orient ourselves first and then determine what's adjacent and what's opposite. I like to always find the hypotenuse first, then decide which side is next to me, and then figure out the one that's farthest away. All right, so when I'm talking about these sides, this is the picture that's in my head, and I want to plant it into your brain as well. Go ahead and make sure you get that copied in. Okay, so we easily see that this is our hypotenuse because it's I don't want to say opposite because that's a different side. It's across from this marker, right? And this number tells us the length of our hypotenuse, 5.83. Remember that we don't really have to worry about scale when we draw polar coordinates. We have to get the angle right, but then we draw a triangle and whatever size it is, we say, oh yeah, that's the hypotenuse, right? It's very freeing. I love it. Okay, so now we have graphed this point. The point is right there. That's the point we're interested in. Oh, okay. But now what we want to do is we want to write that very same point. I'm going to draw an arrow to it because it's so special. We want to draw that, we want to write that point in rectangular coordinates. This title is backwards because we're going to be doing it in the other direction in just a minute. I'm reviewing for you. This is polar to rectangular that we're doing first. Okay, to review. All right, so how are we going to figure out these two sides? All right, well, if we orient ourselves to this angle, which makes sense because that's the one that we know the measure of this angle. We know that this is the adjacent side because it's next to us, right? Adjacent is next to us. And then opposite is the farthest away. Okay, we now know that we've got the size of the angle, we've got the length of the hypotenuse, and we want the adjacent and the opposite sides. This is when we bring out our friends, the trig functions. Let's write them down. Sine, cosine, tangent. Remember that the trig functions say that whatever the size of your angle is, and we use theta as like the mystery angle, right? It's like the x of angles. If we take certain pairs of sides and compare them to the size of the angle for that triangle, we'll always get predictable numbers. And our calculator knows all those numbers. So, for any given angle, the sine is what we call the opposite over the hypotenuse, and so on, right? These pairs of sides, when combined with this degree measurement, will create a unique value. And our calculator knows that it's predictable, and we can use this to solve for missing information. Okay? So what we know is that if we want this adjacent side, we've got the hypotenuse, we've got the degrees. Adjacent and hypotenuse can be used to find cosine. So the cosine of our 31-degree angle will be equal to our adjacent side, which we don't know what it is, so I'm just going to call it A, over our hypotenuse, which is 5.83. Cosine is always linked to this side because it's the adjacent one to the angle. Good to know. Now, before we go any further, I want to point something else out. We're trying to create rectangular coordinates. Those have R's and U's in them. So besides calling this the adjacent side, we can also call this the right side. So when we find out our value for the adjacent side, which is this as well, right? I'll just make this the same so it looks the same. Once we solve for this, that will give us the measure of this length. That will give us the number of units we need to move to the negative right, because that's weird, in order to get to our point, right? This side is important in creating the clues for how to get down here. So let's do the calculator work on this. And my daughter very kindly loaned me her calculator so that I could help you see how to make these calculations. All right, in order to do this, we have to get the variable by itself. So what we're gonna do is cross multiply, and we can imagine this as being over a 1. So we say 5.83 times the cosine of 31 degrees equals that adjacent side, right? Times 1, we can ignore that. All right, so now we have to simplify this in the calculator. And watch me do it. We work backwards. We enter 31, then we hit cosine, then we multiply it times 5.83 equals 4.997. I'm going to round that to 5. So that tells us that our adjacent side is equal to 5. So I'm going to write that in and I'm going to circle it. Okay? That went really well. Now let's try doing the very same thing with this opposite side. If we want the opposite side, and we've got the degrees and the hypotenuse, then what we want to use is sine, right? Sine will be helpful for that because sine relates the opposite, the hypotenuse, in the degree. Last time we were working on the adjacent, okay? So this time, and I think I'm just gonna borrow a piece of paper. Here, let me just rip it out, hang on, because I want you to be able to see. I'm one of those people who doesn't like to rip stuff out of my notebook. My notebooks are art, but that's okay. This problem is art also. Okay, so now we're gonna work on finding that other side of the triangle, the other leg, if you will. We want to find this one. Because if we find this and this, we can use that to write the rectangular coordinates. That's why we care about finding these, is because they're going to lead us to this point. All right? So we're going to take the same strategy that we used here, only we're going to do sine instead. The sine of 31 degrees equals the opposite over the hypotenuse, which is 5.83. See how the two calculations look exactly the same? We just use the different trig function and the different side. But otherwise, they're the same calculation. We'll do the same thing now, where we'll simplify this expression so that it's ready for the calculator. We want to get this by itself. And so we'll bring this up, 5.83 times the sine of 31 degrees will equal the opposite. That one just goes away. This order matters because we use it backwards in the calculator. Let's go. Okay, so this is what we're entering. We start with 31. We enter sine, and then we multiply by 5.83 equals, and it turns out that the length of our opposite side, we're going to round that, is 3. Oh, okay. So that means that this side, which by the way is also our up value, right? This way is right and this way is up. This equals 3. So now we're ready to write our final answer, which I will do here. And I could have done this at the very beginning. We know that our answer is going to be a rectangular coordinate. It's going to look like this. Assign a number on the right axis, assign a number on the up axis. So we go to the right axis. This is the center. So this is the positive rights. This is the negative rights. We know that we need to go 5 units to the negative right. Okay? That is equal to our adjacent side. Right? That's how we got that number, is by calculating this side. That also tells us how many units to move to get to our point. Now, to get to our point, we need to go down 3, which corresponds to this side. So these numbers helped us perfectly. We need to go to the negative up, so it's -3 up. And that's from our opposite side. All right? So when we're doing these, it always helps if we find the adjacent side first using cosine, because cosine focuses on adjacent. Then we use sine to find the opposite side. And we like to go in that order because adjacent gives us the number on the right axis, which goes first in the coordinates. When we write rectangular coordinates, we always put the R first. And then we do the opposite side using cosine second, because that will give us the up value, and up always comes second in our quadrant, or our coordinates. This is correct. Okay, woo, crooked smile. Here's the calculator work. Again, once you get the mystery, the variable on its own side, this is a fairly straightforward calculation. You just cross multiply that up and then work backwards. 31 cosine times 5.83 equals. Okay, that's all the review that we're doing. Now what we want to do is we want to go in the opposite order. We want to take rectangular coordinates and go backwards to find the polars. So we're going to start example 59.4. By the way, there's 3 topics in this lesson. I'm taking them out of order. This is the hardest one, so I want you to do it first when your brain is fresh. Then I'm going to have you take a break, and then we'll come back and handle the other 2, which are unrelated to rectangular, polar coordinates, trig, all that good stuff. And you'll find them, I think, a breath of fresh air. All right, so now what we're doing is we're going in the opposite direction of what we just did. This time, we're going to be given the rectangulars. This is what I wrote on the top of the other page. And we're going to go to polar form. Okay, so this is what we're starting with. We're told minus 5r minus 3u. Those will look familiar because we just created these. I wanted to we'll go in a full circle by the time this is done. Those are the coordinates we're given, and we want to change them into polar form. So what I want to do right off the bat is I want to write right here what I want my answer to look like. And I'm going to start doing this all the time. This will be my degrees. And then I'll have a number here, and this will be the hypotenuse. Okay? This helps me stay focused on where I am and where I'm going, because these problems do make your brain run in circles. Okay, the first task is always to draw the triangle. All right? When we're starting with rectangular coordinates, it's even easier because we're used to drawing these triangles. Minus 5 on the R axis. This is the R, this is the U, right? Right and up. It's kind of a weird kindergarten system. Minus 5 means we go this way 5 units, and so we know the length of that side is going to be 5, don't we? Now we know that we need to go down 3, so I'm going to put it roughly about there. And we know that our point is going to be out here where those 2 intersect. Now, I could write the 3 here, and I will, because that's 3 units down. But once we graph our point, right, we went 5, and then we went 3, and we know our point is there, what we do is we connect back to the center. First connect back to the center, then connect up or down, whichever one it is, to the y-axis. I'm sorry, to the x-axis, but we're now calling it the r. So I'm going to call it the r-axis, okay? So we draw the triangle by first finding the point. And that's easy, it's just old school. 5 and 3, there's the point. And then we connect the point to the center and to the r-axis. There's our triangle. I like to put this in right away. And then this 3, which makes perfect sense, can also go right over here. The 3 is the length of this side. This is the adjacent, and I just use A, and this is the opposite, and I just use O. Last time I used 3 letters. Okay, that's how we draw the triangle. Find the point using these as just a simple treasure map, and then connect it to the center and connect it to the r-axis. There's your triangle. Now, we need to figure out what we need. We need to know the number of degrees that goes here, and we need to know the hypotenuse. All right. I like to find the degrees first, just because whenever I see this shape, I always look at degrees first. So, once again, we're going to have to think about our trig functions. So I'm going to write them in. Remember, our little thing is Oscar had a hold over Arthur. That reminds us which signs go with which trig function. And we see that we have got 2 sides. We've got the opposite and the adjacent. We would like to have this measure, because then we could figure out this, which is the number that goes there. So let's start by using our adjacent and opposite sides to find the number of degrees in our triangle. Tangent is the one we want, because tangent relates the opposite to the adjacent. So what we can say is that the tangent of some number of degrees that's right here is equal to opposite 3 over 5. Okay, here's how we enter that into the calculator. Let me think of the easiest way to tell you. This is a fraction. We need to change it into a decimal. So what we're going to do is we're going to hit 3, these are the buttons, divided by 5 equals, then because we know this number and we're trying to find the degrees, that's kind of backwards than the way we usually do trig functions, which is our hint that what we want to do is we want to hit second, and we want to use the button that says tangent to the -1. That's the button we use when we know the decimal, or the fraction. We're figuring out the decimal right here, and we want the degrees. Okay? So this flow will take this ratio and tell us what number of degrees are in the angle. Let's try it. I know, it's kind of a lot, isn't it? All right. Oh, look at all those notifications. You know how no one else's phone feels quite like your own? That's what I'm dealing with right now. Okay. Okay. Got it. Okay, so we're following this. We're going to take this fraction, turn it into a decimal. There it is, 0.6. Now we hit second, and we notice how these trig function buttons change. They now have little -1s. That means that they are the quote-unquote inverse functions. What that tells us is that that angle is a 31, we're going to round it, 31 degree angle. Okay? This angle is 31 degrees. Now, the number that goes here is not 31 degrees because we don't measure just this. The number that goes here is the number that comes all the way around and goes to there. So how do we figure that out? Well, we take the 31 degrees and we add all of this, which is 180. That tells us that from here to where we want our hypotenuse to be drawn is 211 degrees. All right, that's nice, right? So we're good with the degrees. We've got that all figured out. Once you figure out the degrees in your triangle, then you have to stop and think logically about how to write the instructions that will send a person all the way to the line you want them to go to. We don't want them to go 31 degrees. That would have them way over here, wouldn't it? In this little dinky angle. We want them to go through both of those quadrants and all the way to this line. So we have to add all of this to our 31 degrees, all right? There isn't a standard formula for that depending on what quadrant you're in. You just have to think creatively and problem solve that. All right, now we need our hypotenuse. All right, well, we could use one of our trig functions because now we have the number of degrees and we've got the opposite side and we've got the adjacent side. So we could use sine or cosine, but we have another tool that most students feel like is a little bit easier to cope with. The Pythagorean theorem. Remember that A and B are the legs and C is the hypotenuse. We have both of the legs and we want the hypotenuse, don't we? So if we plug these numbers in, 3 squared plus 5 squared equals, let's call it h squared. Okay, we can easily solve this, and we could do this by hand, but I'm perfectly fine with using the calculator to wrap it up. And so what I'm going to do is I'm going to take the second off. I'd rather be there. 3 squared is 9 plus 5 squared is 25. There's the total. Now I need to take the square root of that. And I want this one. I want the x inside, but the 2 on the outside. And what I get is that my hypotenuse equals 5.83. I won't round that one. 5.83. I draw it into my picture, and then I take it right up here, 5.83. We don't have to do anything fancy to adjust this for the fact that it's over here in the third quadrant. The angle takes care of all the adjusting. This is our final answer. And if you'll notice, it's also where we started. So we started at 5.83 at 211 degrees. We translated that into rectangular coordinates, which we said were minus 5r minus 3u. Then we took those same coordinates and we converted them back to our original 5.83 at 211 degrees. That's a lot. That's a lot. It's confusing. It's circular, but just remember that when you're going from polar to rectangular, we use cosine and sine. Wait, here's my sine. We use cosine and sine, okay? And I'm gonna write this down. When we're going from rectangular to polar, we use tangent and Pythagorean. So let's write that down so that you have it as a strategy every time. So when we're going from we use cosine and then we use sine. This will give us the adjacent side, which is equal to r, and this will give us the opposite side, which is equal to the up value. And our answer will take this form. Sine number right, sine number up. When we're going from polar to rectangular, we use tangent and we use Pythagorean. This gets us the degrees, but we must adjust, right, depending on where we are. So we can't just copy those degrees, we have to interpret them. And then this gives us the hypotenuse. And in the end, what we want our answer to look like, we have this thingy, and then we have this thingy. This is where we put our degrees, and this is where we put our hypotenuse. Remember, this is where we put our adjacent value goes in there, and our opposite value goes in there, all right? And then here's how our polar to rectangular, wait. I wrote the headings wrong. I wrote the headings wrong. I'm sorry. That was crazy. This is when we're going from polar to rectangular. It's like I'm not the only, you're not the only one who needs a break. And this is going from rectangular to polar. I am so sorry. I'm so sorry. That was ridiculous. All the other part is right, but I got the headings wrong. Okay? Because these are rectangulars and these are polars. So yeah, that's how we end up. All right, so this is kind of a little summary of everything that we did to help you find your way from one to the other. If I didn't confuse you too much. This is right. Yay! Okay. What I want you to do now is take a little break, breathe. I'm actually going to break the video just to kind of make sure you have a clear mental fresh start, and then we'll come back and we'll do the other two sections, which are not anything like these, much easier. Okay, thanks, bye.